Alright, so if you remember from last time, we had this example made in Raylib. However, it was like randomly crashing after a while. And what I figured out, like the cause of the problem, was that once we were allocating more memory, it was crashing, right? Like that was the issue. However, if we take a look at for example, at rule 110, let me just generate it. If we run it and try to do like anything with it, we'll see that it allocates more memory than the Raylib example, but it doesn't crash. I'm not sure why it's allocating so much memory. I guess if you use a string as an array, it kind of messes with the memory, so like copying that array so many times. But yeah, basically once it allocates memory, it crashes. So my guess, it has something to do with the way we allocate memory. So we just syscall to break to increase the capacity of the heap. But if Raylib, for example, uses malloc or stuff like that, I guess that's not really ideal for us, because I don't think it's compatible with sysbreak. So my idea for today was to, let's say, have this thing, like have the malloc called in only in one place, like abstract it away, and then try to maybe use something else instead of it. Maybe try to use libc and use malloc, see if that helps. And I mean, if that doesn't help, then there's really nothing we can do about it. And the other thing we can try to do is to increase this size. Let's see how much this is, for example, in Python. So this is how many bytes, and if we divide by 1024, it's like 1 meg. So instead of 64k, we allocate 1 meg. And if we do it like this, you'll see that it lasts a bit longer. So this is also an option to like allocate more memory in the beginning. But what do we do once we run out of the memory, right? We have to implement some garbage collection, and to be honest, that doesn't really sound so fun, to be honest. I mean, yeah, but see, it lasts a bit longer. So I mean, if it doesn't work with libc, in case that fixes it, then yeah, the other option would be to implement a memory allocator from scratch in assembly. I don't think that's really good. I guess it might take a lot of time, so it's not really nice. And the other option would be to increase this size. Okay, let me just check how much is this. Because I don't want to make it okay, so 16 megabytes. This shouldn't but yeah, like it's gonna last a lot longer until it runs out of that memory. So yeah, that's what I'm thinking for today. So yeah, let's okay, so the first place where we can try to do that is inside of object copy. Here we manually take the heap position, then we take the size of the self. I guess this can be turned into some kind of function or something. Let me just I don't know, we'll see if we turn it into a function, but could be an idea, like a macro or something. And then here we take the heap position, then we work with the heap position, and yeah, based on that we call to malloc. So I would say that we can have a function here that somehow ensures that the memory is allocated. And I guess it should probably return the, I guess, the pointer to the start in array_x, and this function should get as an argument how many bytes. So it's exactly like malloc, but we are gonna write a wrapper around it, just in case we want to implement our own allocator. So yeah, let's go ahead and do, for example, let's call it I guess, I don't know, alloc bytes or allocate, because I don't want to shadow the malloc name. No, maybe we are gonna use it. So for the input, let me just check my OCD. Okay, so I think for this one we don't really care about keeping the convention as in our methods, so we can put RDI to be the size, let's say. So we are gonna pass in the size into RDI. So RDI contains the size in bytes, right? Makes sense to have the size in bytes. Okay, the stack should be empty, and alright, array_x is gonna, or the A register is gonna point to the new place in memory. So that's my idea. So let's see, allocate. So basically allocate. For now, how about implementing it just like this? So let's you know, copy the formal the formal stuff that we always copy. However, yeah, we are not gonna save rbx, I think. Like, there's no point. If we want to change it, then we don't. Although let's keep it, because I also was reading about that thing with the stack being aligned, like the RSP pointer having to be aligned to 16 bytes for the XMM things to work. So basically this would align it, right? If we have like one word, then we push the second word, now it's divisible by 16. Then we push 3 words, it's no longer divisible, but we push another one and it becomes divisible again. So that's why I have random variable allocations all over the place to make it divisible by 16. So yeah, like if you need 2 variables, put 3 and it's gonna become divisible. Alright, so no, let's just keep it to be able to save the self in case it's needed, but it's not gonna be needed. So yeah, might as well just not to worry about it. So yeah, then let's just, you know, we are gonna allocate 4 variables if it's needed, but let's see how many we are gonna need. So we are gonna take this t0, right, which is gonna be the heap position. Perfect. Then the size is gonna be passed into the function, so we don't worry about it. Then we need to compute this variable, which is gonna be, let's say, t1, and t1 is gonna be this plus arg 0. So here instead of this we should do rbp plus arg0. All right, rbp plus arg. Although what I'm not really sure about, it was plus 16. Is it plus 16? So yeah, here for example I was taking the first argument and it's working. So it's RSP plus. Okay, because... But why did I use RSP plus? It's a bit strange. I'm curious to see like maybe the concat function. That's more, let's say, more interesting because concat also takes in an argument, right? So I said rbp plus arg0, and rbp is gonna be saved here, right? So it's not gonna be influenced by the local variables. That's what I wanted to know. These are the local variables and they are influencing only RSP. So that's why I said it's a bit weird that exit is actually working with RSP here, but you know, it just happens that I guess for some reason I just changed it to RBP because that's how it's supposed to be. I guess allocating this one variable was making it working. I don't know. Strange though. Anyway, let's go back to our stuff. So here we take the argument 0, we add it to heap position, and now we can check. But I mean, you already know this, right? From when I did the object copy. We take the heap position, we check. Now we have to check if the size is, I guess, alloc. Okay. I guess if the size is too much or something, right? So if it exceeds heap end, that's when we have to allocate. So here we need to call to malloc. And as I said, let's use the old version for now. And I guess this will be called like old allocate, which works with the heap position and heap end. This is like the really basic way of allocating memory. Like if you remember from the allocator project, that's how we were doing it in the beginning. We were just having 2 pointers and always keep increasing the size. But afterwards we also implemented free and nodes. So we had a bunch of nodes, like a linked list, and we were freeing and like setting the nodes as free or occupied by something. So that's maybe how we are gonna also do this if malloc doesn't work. So we'll see. But yeah, so we only needed 2 variables, and as I said, since I want to keep it 16 byte aligned, I'll just use 16 here. Okay, so after we call to malloc64, malloc64k, right? This just changes the heap end. I don't know what it does though. Right, it's changing the heap end. So what we are gonna do here, we have to return the first variable. So, and the first variable is the heap position, so that's what we need to return, right? And I guess we also can increase the heap position like this. So let's also include that, right? So we can increase the heap position and say it's gonna be equal to the first variable, or I guess second variable, and this is return t0. So I think allocate, that's how it works, right? So yeah, basically allocate just moves that heap position. So now let's try to use allocate instead of what we are already using. So inside of this one, we are no longer gonna need t0. We are also gonna need just getting the size. We also don't need, I guess, this or this part. We only need to say something like t0 is allocate t1, right? So we move that into RDI, we call to allocate and move it back to t0. All right, we might just move variables around, but it's good for now. So this mem copies stuff, right? It mem copies to t0, like the place in memory that we just allocated. It copies t1, or I guess self, and it uses t1 bytes to mem copy it. And usually this was the place where I guess the segfault happens, right in memcopy. So this kind of tells me that allocate didn't allocate good memory, it allocated some trash, and the memcopy failed because of it. So basically that's. And here at the end we just return t0. So yeah, I would say that this should be all for object. So if we run make, everything is done, and let's go with rule 110. Right, we don't even need to add the module prelude, like the prelude is added by default. I just wanted to have let's see, different modules that you can use, and like data and prelude are gonna be default. I might make data optional, and then you can add Raylib. So when you compile something like rule 110, it automatically adds module prelude and module data like this, right? And if you also do something with graphics, you can add Raylib. And not sure about Raylib, I just have this from a project, right, that was doing Raylib in assembly, I guess. Phasm Raylib example, something like this. It's from coding, right? So yeah, pretty good example though, but it's like everything was put in start, so yeah, I guess it just works. And he didn't need like to allocate memory using sbreak, so yeah, that's like the entire memory of the program is, I guess, this thing, so pretty funny. Yeah, anyway, so I have that from here, and also tried to external Raylib to compile it from source, but still the same thing. So I guess it's not because of Raylib, you know. So, yeah, and I was showing that you can add this module and the compiler will pick it up, and you know, we'll have to figure out how to set the path. Like I wouldn't really want to do, you know, else slash what's it, user lib or something. I guess if you install Raylib using your package manager, that's where you find Raylib. So yeah, not sure if the compiler should depend on doing stuff like that, or if it should just have the like library inside of the repo, although that's pretty big, so I don't like that. But yeah, we'll see. Anyway, so yeah, as I was saying, I was trying to recompile this thing. So if you check the main file, you'll see that it's statically linked because it's just linked it. Right, so if we run it, oh shit. Okay, so something did not work in the allocation. Let me just check. Okay, so I actually found the issue. Here I was saying, oh, let's take the size from arc0, but I forgot that I said that we are going to use RDI. So instead of arc0, we have to use RDI. And here I forgot to also update this to be the first variable, or I guess second one. And now if we just recompile the game and call to main, looks like it works. I guess it was a weird example, but yeah. And it looks like it only allocates once now, which is a bit strange. Like it stopped spazzing. Pretty curious. No, like before I was just doing it inside of copy, it was really spazzing out when who knows. Let's try to recompile also Raylib and see if like it looks like it works. I guess I forgot to change it back to only 64K. So now if we recompile rule 110, we should see it spazzing. Yeah. Okay, anyway. So we have the allocate and it looks like it's working fine. Let's go back to it. Okay, here. Looks like it works the same way as it did before, right? So that's good. So perfect. All right. Let me just check memcopy for a second. I guess memcopy works. It's like memcopy from standard library. So nothing special about it. All right. So let's continue. Type name. I guess this just returns I have no idea what it does, but it should just return the local variable, or I guess the constant. So it takes the class name table, then the size of the self, then we have t2, t3, oh, this is the tag. Oh, object tag, yeah. I was like, what the hell was I thinking? But yeah, if we take the tag and we index it into the name table, we get back the constant with the name. So that works, that checks out. Here when we do object equals, right, I guess we do object copy, so we don't really worry about memory allocation. Like the memory allocation is abstracted away into copy, so that's fine. Here when we, I guess there's a better example with a to do. Here when we read a string using the read syscall, we create an integer, then we create a string, right? However, this string is not really, let's say, allocated yet. Like the memory from the string pointer is nothing there. So what we can do is to allocate straight up an array, like a string that has this many bytes, count bytes, which come in the first argument, and return it here. So we can have some kind of a create string function which creates a string object with this many characters, and of course empty characters, but characters nonetheless. So yeah, we don't have to do so much stuff here like malloc and stuff. So yeah, basically let's try to do that right now. So it's gonna be allocate string, right? So it's gonna take this input, it should have the size of the string, right? Should have the size of the string. It wanted something, contains the string object, like come on, man. I would really like to just allocate the entire string with everything. So we're gonna do, the stack is gonna be empty, and this is gonna point us to the string. So allocate string, right? So let's just copy some of the stuff, and as before, we are not gonna, let's do 64, like 8 variables, just in case. Right, so this is gonna be 64, almost. Nice. So first thing first, I guess we still have to create this stuff, right? What? First thing first, we create the int object, the string object. I guess actually, yeah, let's keep it. And how about, no, let's just keep it empty for now. Like this is gonna represent the count, and RDI is gonna represent the capacity, if you think about this thing like a dynamic array. And so it's gonna be the count and the capacity, and the string is gonna be the items. So what do we have to do? I guess we have to set the size of the object. So for example, here is where we do that. So let's take the size. And what I'm gonna do is pretty scuffed. So here we create a new string, we copy it from the prototype. Now my idea is, let's set the size of the string or the capacity to be the count, basically, you know, use the count to be, I guess, the RDI to be the capacity of the string, and then copy it again. So that's my idea, which I guess does 2 copies, but we don't really have a way to specify how many, like we don't have a way to specify the capacity of a string when we copy it. So I mean, it is what it is, right? So yeah. Okay, so here we create a string, right? To get the capacity, let's get it into, and I'm not even sure if we need the integer. I don't think we need the integer. Let's delete it. So we're gonna have, the string is gonna be in t0, right? We're gonna have t1 is gonna be the size in bytes, so this should be RDI, right? This is gonna be the size in bytes, and this should be t0 and this should be t1. Take our variable, take the object size, set the size, and wait a second, we don't even need, oh yeah, we need to copy it because we need to reallocate the memory from here. Yeah, we kind of need to reallocate it. Now, of course, you can say that we'll also do a call to free, although we don't do anything. I guess the first step would be to create a new string, right? It's gonna be t1 dot copy, I guess. So we move into RAX, we move, well, it's t0. It's gonna be t0. We copy it, we string initialize it, and here I guess we can put it into the second variable. Then should we free t0? Like, that's a good question. Maybe we want to free it once we have some way to do it, but now we cannot do it. It is what it is. And here we want to return t2. And as you can see, we have 3 variables. So let's use here 32 for 4 variables, just to keep everything aligned. All right. So I think this is how allocate string should work, right? We create a new string from the prototype, then we calculate, we compute the size of the string, how much it should actually be, although here we just set it. I don't think we want to just set it. I think we want to increase it. Let me see. So what is T5? T5 is the read syscall. Okay. T6. Yeah, this is pretty scuffed. This should in fact be increasing the size, maybe increasing the size -1. Because we already have some size in the object, and that represents, you know, takes into account the tag, the size itself, the dispatch table, the integer object that represents the number of characters that are being used, and yeah, then the string itself. So it should be +4, right? So and yeah, I guess if we take a look in the assembler when we create the constants, let's see, when I create the constants for string, I do 4 plus words, right? But words is always gonna be, let's see, if the string is 0, like nothing, this is gonna be word size divided by word size, so it's gonna be 1. So yeah, we're gonna have at least 1 byte allocated for the string value. So let's just say it's gonna be string size plus, because yeah, the other option would be, but I don't like that option, would be to have the string being a pointer to a string, but that requires so many changes. Yeah, it's not a good idea. So this should actually be size t0 plus t1, and if we are really pedantic, I guess we can have -1, right? Shift right, okay. Like that's another way to do it. So here, what can we add like that? It's a bit scuffed. So I guess we no longer need RDI after this step. Well, first let's do something else. First let's do T2 is gonna be size of T0 plus 1. So it's easier to think about it this way, right? So we take that, we take the object size, we dereference it, and now we add that and we move it into that. So now this should be just T2. So it's easier to think about it like this. And do we really want to do -1 here? Let's just leave it out for now. We don't really care about -1 there. So that's that. Let's change this to T3, and now we really use for variables, so it's fine. So yeah, we create a new string, we compute the size that we want to allocate based on the argument, obviously. Then we just, you know, set the size on the object that we just created. However, that's not really enough, right? We have to copy it once more. Yeah, just because the memory is not really allocated when we do this. We just say that we want this size to be the real size, but you know, it is what it is. So here we actually create a new string. So I think creating a new int is fine, but we have to replace this stuff with our new function to allocate string. So it takes in RDIS size, and Rx is gonna point to that. So let's say that T1 is gonna be allocate string, and it's gonna take the arg1.value. I guess we can try to just rewrite it. Because it's gonna be annoying. So T1 is gonna be actually arg1.value. So let's see. We take the first argument, we take the int slot, we dereference it, and then we move it. So classic. Even Copilot learned how to do it after I did it so many times in this file. So this is gonna be T1, right? So we just have to move the variable into RDI. We call to allocate string, and then we have to store RAX. So now we have the string in T2. Alright, so let's see what's next. So here I was, taking this thing, doing the malloc if it was required. So we don't have to worry about all of this stuff anymore, so we can just delete it. Although I think we might need T3 being equal to this. So we take the reference to the string, which is now allocated. We don't have to worry about it. Perfect. We need a file descriptor for some reason. Sure, take it from arg0, right? Then here we have to call to the syscall, the read syscall. So how read works, it takes in the file descriptor. We can also just make sure that we understand. It takes in the file descriptor, the buffer, and the count. So the buffer is T4, T3, like this, and the count is gonna be T1, right? And this is gonna be T1. Okay, and the syscall is 0. So after we call this thing, we are gonna get, I guess we get back the number of bytes that we actually read. It has to say here in the, or -1 if it's an error, but we don't handle errors. We are very confident that our operating system will work. So here we set the value of T0, which is the integer. It already exists, it's fine, everything is good with the integer object. So we set it. Then we set the integer reference that we have on our string, which is T2. Yeah, we set the reference to the integer object, obviously. I guess the integer field of the string here, we set it to T0, which we initialized, so that's good. And I don't think we need this anymore because we already set the size, and heap position is already set, so that's enough. And here we want to return the string. All right, so 7 variables. I guess we have 6 variables, but since we need to have it 16 byte aligned, I think it's fine. So I guess this should be it for the read syscall. Let's see if everything is working. Obviously stuff compiled because we are changing assembly, so if something crashes, it's gonna crash now. All right. I guess time for GDB, you know the drill. Okay, so actually found the bug. So first problem, I guess, was here I was returning T1 instead of T2. Here I was again doing something stupid with T1, and the other one, which was even way worse, was that I was doing this assignment using RDI after calling to some functions. And if you know in x86-64 whatever the assembly, function calls are not really gonna save RDI. Like RDI is gonna be used as a temporary stuff in most function calls, so it's not a good idea to do it after function calls. You have to at least store RDI somewhere if you want to do it in that order. But I said, well, let's not do that, and just moved it first. So still works, right? Still works. Now we use allocate string in our Linux read instead of calling directly to malloc and stuff. So this is good. And allocate string also doesn't call directly to malloc, it calls to copy. It calls twice, but now it is what it is. And we also allocate, like if you do read 1 million, it's gonna allocate that memory, right? But if you think about it, it still has to allocate that memory regardless. So yeah, so it works and everything is good. So let's see the next one, which is similar. So here we want to create a string. So let's, okay, I mean I spent so much time in GDB, I forgot how I did it. So let's go to Linux read. So read creates the integer, then we take this. Am I stupid? Okay. I mean, it looks so similar. So here we take the first variable and we allocate the string. So let's go to int.chr. So instead of doing this, right, it's still gonna be T1. We want to allocate a string of size 1. At least that's what I'm thinking. But since we want to allocate bytes and we want to be somewhat aligned, we should do 8, I think. But wait a second. I just have to double check. RDA contains the size in bytes. Ah, okay, so if I say 1 byte, it's gonna do everything automatically. Nice. So let's say we want a string of size 1, so it's gonna allocate 8 bytes for us. It has to be aligned. So we have to move into RDI 1, right? And not forget about this the second time, or I guess the third time or fourth time this time, like in this coding session. So here we allocate a string of size 1, as I said. We save it into T1, so this is not needed anymore, right? I would say that we still need to store the, I guess, reference to S, but we don't need to do this stuff, right? So we can do only this. We allocated it, we made sure that it's allocated. We take the string pointer And I guess here we take the integer value and we put it into the string. Right, we put it into the string, and that should be okay. So let's go back to allocate string. See, I guess in this example with Linux read. So I still set the values, but should be easier to do. So we created the integer, we allocated the string, we took this reference, we took the number that we want to set as a character, we set it, then it's gonna be 1, right? I guess we can we can use t3 as a 1 since it's not used. So we have t0, t1, t2, t3 can be a 1 if we really want to. So t3 is gonna be equal to 1. All right. T3. Okay, so we allocate the string with that size, keep the pointer, get the character code, T3, one second. So yeah, we take the integer, the int slot, the value from T3 and set it. Then we set the L to be L, obviously. Yeah. We set the L to be L. And I don't think we need this. And at the end we just return stuff. And how many variables did we use this time? 4 variables. So we can say 5 here, right? And it's gonna be 40. Again, to keep the stack aligned. Alright, so make won't do anything, obviously. And if we recompile this and run it, not sure if this uses CHR. No. Let me just check. So this is rule 110. Does it use CHR? It does not. But this uses the array.cl, and this should use CHR, doesn't use CHR. Interesting. Let's do an example. New IO out string 69.chr. So let's build. I mean, okay, don't judge me, but I know that capital E is the character code for 69. Alright, so if we go back into Prelude, looks like this works. Perfect, it works. Oh my god. So what's next? Ew, concat. Yeah, but it shouldn't be more difficult. That's what. No. Okay, let's take this thing. So we have to somehow figure out how many let's say how many bytes we want to allocate, right? So I guess that comes from self and s. So I see that here we compute the size into T4, which is genius. So this takes the self size, this takes arg1 size. I was like, can't I just use the size of the object? Nah, not really. It's nicer to use the length. So here we need to say something like this. So T0 is gonna be the integer where we are gonna store the thing. Then T2 is the size, like the string length of self. T3 is the string length of arg1. T4 is gonna be the sum of them, so the new length that we want to allocate. And sure, we allocate it. Why not? Pretty easy. So now in T1 we have an allocated string of pretty huge size, right? So that's the first step. Then we have to do two mem copies, right? First mem copy is gonna be from self s into T1s, and the size is gonna be self L value, or let's say better that it's gonna be T2, right? Makes more sense. So T1s is the destination, self s is the source, and T2 is the size. Then for the second mem copy, destination is gonna be T1 plus T2, right? String length. The source is gonna be arg1s, and the count is gonna be T3, I think. Yeah, it's T3. Perfect. So that's the second mem copy. Then we need to set the integer, like the string length, set the integer value to T4, and then set the pointer to that new integer. So we set the length on T1, that stays the same. And here we were computing the size of the object, but we don't need to do that because it was already done in malloc. So here we just return T1. And very cool. So I think we still use 5 variables, right? The same as for the other one. So I think we can just remove that. Perfect. So that should be it for concat, right? With allocation, keeping the allocations in only one place. That's good. So let's try to concat, I don't know, new line. I mean, if it works with new line, it should work with anything. Okay, is 69. And first try again, 69, keeping us safe. So build. Which one? Rule 110. Rule 110. Okay, so main. Looks like it's working, I guess. You know, it was rule 110. It was that cool string that was repeating itself. Which one is it? This? Something like that. So yeah, we have it twice, right? So it means that it's repeated. Okay, perfect. So back to the prelude. So concat works, only one allocation, or I guess, you know. And the last one, I think is the last one. Let me just check to the, yeah, it's the last one. The last one is gonna be pretty similar. So let me just, and I guess similar because it uses allocator. So yeah, we have to do allocate string, and this time we get the length as the second argument. So I mean arg1. So we need this thing to be called before, and that's the new length, right? Argument 1.value. Then we have t2 as usual, just the index from where we are gonna start, and we can remove all this crap. So obviously again a mem copy. Who would have guessed? So the destination is gonna be the string t1.s. We just allocated that. The source is gonna be the self string plus t2, which is the first argument, and the side is gonna be the second argument. So we run memcopy. That's pretty good. Here we set the value of the integer, and this can be removed. Perfect. So we return this. So glad that I was able to clean this up. So we have 4 variables, but that means 40, just to keep everything aligned. Okay, then we have this string ord, but it doesn't malloc anything. And finally, malloc is called in only one place, right? So yeah, I guess even memcopy or memcopy is called in multiple places, but it's a standard library in quotation marks function. It's like really simple. It doesn't do anything special, but this one has a syscall, and it was a bit I mean, I would say that I get why you would want to have wrappers around syscalls to not, you know, throw them around. So yeah, I mean, this is the important one. But yeah, now we have allocation just in allocate, right? So that's the point. So if we look at call allocate, we call it once here in the, you know, I'm curious, does it work? Doesn't look like, you know, the 3-seater header. Hoping to see this. So here we allocate the string when we do Linux read, right? That's one place. Then in object copy we call to the real allocate. Then inside of int character we allocate a string. Here again allocate a string. In string concat. In string substring we allocate another string. And yeah, I guess we go back to the start. And don't we, inside of allocate string, just want to see something. Inside of allocate string, we don't even call to allocate, we just call to object copy. That's even nice. So yeah, I guess I can move these down just to have them at the end. Ooh, nice place to begin allocate. Okay, and let's also move allocate string down there. Right, so allocate string is gonna be somewhere here. Alright, so allocate string and allocate simple. Yeah. So the entry point, the syscalls, yeah, we have everything. Everything should be good. So let's comment this thing out. And let's see if the checker works. Please work. God, yeah. Whew, it worked. So I guess there's not really a point in checking Raylib because it's gonna crash, right? We do the same memory allocation. But the interesting question becomes, what if we do the real malloc? So let's say we have an extern. Okay, let's first of all let's do a commit, I guess. I mean the main, whatever, the main is trash, so okay, let's not commit that. Let's just commit. Well, it's gonna be easier to unstage it, so I want it to zoom out. So this stuff is useless. Yeah, not sure how I want to store Raylib, so for now I'm not even including it, even though that means that you cannot really use Raylib. I mean, you can add it yourself, so okay, this thing shouldn't really be part of this commit because it breaks everything, and also this one. All right, but the rest of it should be, or I guess it's refactor. Move the malloc to a single place call, I don't know, something like that. So yeah, how about trying to have extern malloc? Right, it doesn't even matter where we put it. And now let's say that malloc64k, to be honest, that's the name it's gonna have. It's not gonna change. Ooh, one last thing. Though we do fuck around with the heap end. Here doesn't matter. But inside of allocate. So actually we want to replace allocate, not malloc64k. Then that means that we can just go inside of this, and instead of calling to it, we can just do this stuff. right? This makes sense. And now we don't even need malloc 64k. It's useless to us. I think this should still work. Although let's check. Let's double check with the checker. Yeah, it's a bit slower because we compile it with LD, not just FASM. When we were doing, oh, we don't have that here. It's inside of allo assembler. I'm so ELF64. Really? Yeah, we specify that the format is ELF64, but we don't say it's executable. We just say this, so it will make it, I guess, object file. Yeah, it is what it is. So it's a bit slower, but that allows us to link with Raylib, standard library, or I guess libc. So yeah, this is what I would change. Let's see where we use in any other place heap end. So heap end, just in allocate, that's perfect. Heap position though, just in allocate, that's good. Oh wow, just in allocate, that's perfect. That's really nice because it means we can have another allocator. So it's gonna be called mallocate. It should be the same thing as contains the size in bytes. The stack is gonna be empty, and that's that. So this is the like libc version, right? I guess I'll be able to use yeah, it's you have to use lc. Perfect. Let's see how it goes, because if like we can implement our own allocator even with like garbage collection and stuff by using libc, although I, yeah. So how do we want to do it? I guess malloc. I guess you just pass in the size, right? Just pass in the size, and that's that. So yeah, I mean, it sounds too simple, to be honest. So RDI is already set. So it's what? It's just call malloc. I mean, it's just malloc. Am I missing something? Yeah, I don't know. We'll see. So let's define extern malloc. So the only issue, well, I guess it's not really an issue, but if we try to compile main, it's gonna complain, right? So to be honest, I would maybe put this thing like create two allocators, right? And based on the module that you use, right, if you use simple allocator, like the one that's, you know, the classic for cool, you use this allocator, and if you use the libc version, you use this allocator. But yeah, let's link with module Raylib just to include the libc. And now if we run, everything should be working, right? But if we go where we call allocate, right, and use mallocate, should be only one place, right? Let's see what happens if we try to use malloc. Whoa, worked. And how about Raylib? I mean main. Didn't crash yet, so that's a new one, and it still doesn't crash. So, ladies and gentlemen, we have Raylib inside of the cool language. That's a new one. Pretty sure about that. Pretty sure about I guess, I mean, yeah. So yeah, that's my plan, right? To have two different allocators. One, like, be able to have cool as if you choose to use the simple allocator, right? No, it is what it is. Use the simple allocator. Let's just I mean, this makes it a bit harder. But we can still make it. So let's say T0 is gonna be equal to RDI. So please do it for me, ChatGPT. And here, let's say move RDI, take the size. Right, so let's see how many allocations happen using malloc. Quite a lot, but yeah. Wow, that's so many. Let's see rule 110. Huh. Yeah, I guess it's because we allocate each object individually. That's so, I mean, that's even better though. Right, for some reason that's a bit better, I guess. I don't know, we'll see. So yeah, pretty cool. So yeah, it's still gonna be called allocate, but we are gonna have two modules. One is gonna be basic allocator, and the other one is gonna be libc allocator. Right, so let's do it now. Let's call it mallocator. All right, mallocate.asm. It's a pretty weird name, so it's not gonna, you know, deter the users from using it. All right, so let's, funnily enough, this is the only thing we have to copy there. So mallocator, right? So this function allocates. Perfect. Like Copilot is really good at generating documentation and comments. Right. So allocate. I guess if you have a couple of good comments, it's gonna keep generating good comments. But if you have trash comments, like I do here, it's gonna keep generating trash comments. That's the only way. And I guess allocator is gonna be allocator.asm. Let's call it mallocator. And allocator is gonna be the simple one. So let's also copy it. And yeah, basically we are gonna have to also move these. That's interesting, because also the entry point, the entry point changes a little bit. So maybe I'm gonna do another function, allocator init, that's gonna be called here, right? And I guess this is for prelude.asm. So let's take the section data writable. Okay, let's make this a section text executable, right? So this is the memory layout, I guess. And let's also have allocator init, right? So this is gonna shouldn't have any input. Prelude.asm. I'm curious. Input contains self. Okay, input doesn't contain anything. Wait, it's like, what is object abort? It's the syscall. Yeah, never returns. Okay, so nothing. Stack empty, and the output is gonna be nothing. So what it's gonna do is this syscall, right? So allocator init. Let's still do the push, pop, and return. So this is gonna be aligned anyway. So this initializes everything, right? We have the memory layout, pretty cool. So now instead of having this section here, we can also move this one for the moment, even though we will delete it. So this comes here, and here we need to call init allocator. Should we call it init allocator or allocator init, right? So I think this looks cleaner. Maybe here we can call to Linux exit. Rx contains self. Stack contains. Anyway, let's not worry about that. Okay, so now we have the allocator here. I don't think we have any it remains left. Only allocate string, but this is basically string new or something. I guess we can call it string.new, right? But that's gonna mess with the naming conventions. We can do something like string underscore dot new, like private function or something. Anyway, so we have allocator init, we have allocate, we have the data writable, section executable. So let's take this guy. Let's go into mallocator and also add it here. And the last thing I have left to do is to copy the section executable. So yeah, this one also, I mean, this doesn't do anything. All right, so I think this should do it, right? Well, I mean, I still have something left to do. I guess in util.h I have to say define module allocator is gonna be allocator, define module mallocator. Yeah, like this. So I guess these two are gonna be XOR, like, no, mutually exclusive. But we can try to use, for example, module allocator with Raylib. Oh, args, let's see. I don't know how to do this. I guess define modules is gonna be define modules count. Can't I do like, you know what, I'm not gonna worry about it. I guess I can do a const char like this and have const size t module size. So this should be the same thing. So let's say int result is equal to 0 result, and we are gonna do a for I is equal to 0, I is smaller than modules size plus plus. We compare with module. Okay, so we should have maybe found then. So I have found, right? If not found, like that, I think is good. So this validates the stuff. Okay. We have another one. Else if string compare module mallocator equals to 0, Then we have to use libc, right? And it's also gonna be dynamic. And I think that else if string compare module allocator, we should just continue if it's the simple allocator, right? Something like that. Whatever differ, you differ. We probably also need a function to validate the modules, so something like, but I mean it's gonna crash, well, int found alloc, found allocator. So this searches for the allocator, I guess, right? Int found mallocator is equal to, so let's not break, let's just have an else if it's mallocator. Then if found cannot use both, but here I would say it's better to use it like this. If we didn't find any of them, right, I guess we use the default allocator, right? And I would also then just use this, right? I think it's better to put everything here. Let's put this first though. So this is gonna be an else. Right? So if we find prelude, we have found, so on. Here we can close the for loop. Right? We check for that. And then we can try to use, like if we didn't found prelude, we add it. If we didn't found data structures, we add it. And I think yeah, append default modules, but maybe it should be called differently. If we go in main and search for append default modules, like maybe I would call it util post validate modules, right? Something like this. So now if we remake it, wait, what? Oh, is it in util.h? But what? I thought that I have an if not defined. It doesn't work like that though, I guess. strange. So let's go into args.c and whatever, define it there. Alright, so if we try to compile like this, wait, what? Why does it say undefined reference? First of all, yeah, prelude.cl, no, prelude.asm, we should have like a call allocate. It should be call allocate. But I thought that it should wait, what? I still have this crap. Oh, it's no longer showing the message, right? Okay, let's show the message, at least in one of them, to be able to see. So let's say move R di1 RSI RDX. Let's see. Right, so now it calls this one. But if we say module mallocator, it links with libc, pretty cool. And now it uses this one. So yeah, you can link with Raylib, like use the Raylib module, and if you run main, wait, what? Because I have to use, also I have to use Raylib.cl. So this links with Raylib, right? So now if we run it, it will crash because we use the bad allocator, or I guess the default one. But if you also say mallocator, it will use the good one, so it won't crash. And yeah, at this point we can actually create a game in this crap language. How about that? I guess it should be like something really simple though, like let's say Pong or something like that, some kind of Tetris. So yeah, now we actually have Raylib working, right? And yeah, that's the only thing I'm not really sure about. How should I include Raylib into the compiler? Should it be like the precompiled library, or should it be the Git submodule with the repo and we build it in the make file, something like that, right? And then when we create a distribution of the compiler, like the build folder, we can copy here, or like, you know, we copy the main executable, so something like build main into cool C, and now we have cool C as the compiler. So examples, and let's say rule 110, and then we can, you know, run it, right? So cool C help, basically like this, right? So we're gonna have a cool C executable and then we should have like a library, right? Like one way would be to depend on you installing Raylib with, you know, apt-get, for example, or with pacman, and do it like that, or continue to use the other way is where is it, cool home, to define this environment variable cool home, and basically cool home tells the compiler where to find the lib folder. And I guess based on the cool home, but I'm not doing that, sadly. I should though do that when I'm running the linker. So when I run the linker, I should probably here like util get ld flags. When I generate the flag for this, to do use cool home to get the path, right? Like I can use cool home to point to this thing. And yeah, I guess after the build, right, it should generate a Raylib folder, and inside of Raylib it should be raylib.a. So I guess it's going to be like this, but for this, instead of this dot, we are going to use cool home. So that's the only change, right? Like with this, and it's going to use current working directory. But yeah, maybe I should also put, wait, where I'm using the button, no, I'm not using it. So let's say cool home. Well, first of all, let me just go into the allocator, remove this thing. Let's make sure that the checker works. All right, let's do a commit first. So we added the allocator, don't care about the rest, right? Yeah, so feature allocator modules. Okay, so now we can actually change this. So I would say this could be cool home, right? And here let's set context. We set the context, and in ld run, right, I would say that this should get the path. So context cool home, like it must get some information. Yeah, I think the modules and the cool home should be enough. Yeah, so this should be a char pointer cool home, right, like this. And now where's the to-do? So this is gonna become like this, and I can say something like int needed is gonna be string, no, sn printf, right? Come on. We allocate needed and then we sn printf that. The only thing that I have to see is, well, this should be enough, but yeah, I guess that should be enough. So for example, let's say that I'm gonna create a folder for cool compiler as an example. Let's see what happens. So yeah, I forgot, it's util cwd. But doesn't matter. So let's rebuild this. Right, let's copy this into this. Let's make a directory. Maybe we are gonna call it cool C dist or something. Let's move cool. Well, we don't have to. We just have to copy recursively the lib into cool C dist. Right, so le cool C. We have the library there. And let's also copy Raylib into cool C dist. Right, so now we have both of them there, right? And I guess let's cd into, I don't know, here. Let's make a directory test cool game, cd into test cool game. Let's copy cool compiler slash cool C into here. Examples, and let's take Raylib here, right? So now if we try to run cool C on Raylib, it's gonna fail because no such file or directory, right? So if we export cool home as being, you know, home Alex personal cool compiler. Oh, actually it should have worked without me creating the folders, but can I just export it and then run it? Oh, because I have to say module Raylib, right? Whoa. So now if we run main, all right, so we can, well, one second, module mallocator. Okay, so actually, yeah, we can, you know, just use the compiler from other folders, like use the executable. So yeah, that's nice. All right, so that means that we can add these changes. So feature -l based on cool home, right? So then, yeah, I guess just judging by cool dist. I guess I'm gonna include maybe Raylib as a git submodule, and the build system, like make file, is gonna build Raylib, and it's gonna create this Raylib subfolder. And I think that should be I guess that's how the workflow is gonna be like when you build a compiler. And maybe, I don't know, also generate this cool C dist that you can just copy paste it. Maybe also include cool C into it. And yeah, have cool dist, which you can then use. Yeah, I think that's a good idea. I don't know. If you think you have a better idea, please share it. Yeah, I'm not really, I mean, I don't really know how to, build C projects, like how to structure them well with dependencies and stuff. I guess who uses dependencies in C? Okay, so yeah, I guess this was really good progress. We actually managed to fix the memory issue of Raylib, and now we actually have I mean, just to prove that it's just kidding, but it's here, right? It's a class inside of cool. We don't have that many functions ported yet. It's just clearing the background, drawing some text, drawing a rectangle, but I think this should be enough to make a really small game. So yeah, I guess that's the plan for the next one. Add more colors and make a really simple game. I don't know how well it's gonna run. So yeah, I guess I'll see you in the next one. So see you.